We present Magic123, one image to high quality 3D object generation using both 2D and 3D diffusion priors. We target the task of 3D generation from a single image. The input is a single image in the wild. The output is a 3D representation. Since the novel information is missing in the task, thus, how to utilize priors for novel view guidance is the primary focus of the field. Real Fusion used SDS and added a reconstruction loss to reference image, which allows the stable diffusion-based generation of 3D content from a reference image. But most of the 3D generation lacked consistency despite great generalization. 0123 showed great potential for generating consistent 3D from a single image by training a view conditional diffusion model on synthetic dataset, Observers. But they lack generalization for uncommon objects, and sometimes they generate very simplified 3D content. We introduced Magic123, a novel course-to-find pipeline for image to 3D generation that uses a joint 2D and 3D priors to guide the novel view. Using the exact same set of hyperparameters without any additional configuration, Magic123 produces high-quality, high-resolution 3D content and achieves state-of-the-art on image to 3D results in both real-world and synthetic scenarios. We use a course-to-find approach from inset NGP to the first stage and tetrahedral mesh representation for the second stage for fine-grained generation. The pipeline utilizes a pre-trained stable diffusion and textual inversion of the reference image and the combination of losses from the reconstruction loss. The guidance loss has two main components: the standard 2D SDS component that uses stable diffusion output and the 3D prior for using a pre-trained 0123 for consistent 3D guidance loss for specific views. The main intuition behind combination of 3D and 2D priors is that 3D priors typically are more consistent but lose some generalization, while 2D priors tend to be less consistent but highly generalizable. So the trade-off between the two priors give rise to a sweet point in between that, which gives both consistent 3D and generalizable 3D as well. Here we show some results of Magic123. Note that the details and the consistency of the 3D generation from the single image shown. More results. It gets state-of-the-art results compared to the strong and reasoned baselines in terms of PSNR to reference image and average clip score from different views. Here we show some comparisons to the baselines. Here we show the results in terms of joining both 3D and 2D priors and in terms of using single versus two-stage approach on two different datasets, the Real Fusion and the NERF4 dataset. We compare Magic123 full with Magic123 using only the 2D prior and Magic123 using the 3D prior only on the scenarios of human reconstruction. The 2D prior produces inconsistent 3D content and the 3D prior yields simple geometry and texture. The Magic123 achieves the best quality, demonstrating the benefit of major contribution of our work, the joint 2D and 3D prior. See the shoulder and waist geometry of the Iron Man examples on the top row, the thigh shape for the Lisa example in the second row, and the shoes for the Taylor Swift example in the bottom row. Here we applied the trade-off hyperparameter lambda 2D, which leads to higher imagination of generative power when we increase it, but less 3D consistency, and vice versa. Here is the video for immersive visualization. Here we show some shortcomings and limitations of our work. One limitation is the discontinuity in the generated 3D. As you can see from the reference loss that's explicitly defined versus the other views with SDS loss, there is discontinuity that results in the discontinuous texture, as you can see here. Another problem is with complex objects and complex topologies. This method seems to fail or lose some details. Please check our website and the code attached for more details. Thank you.